Hi everyone, welcome to RK TechLearning. So today I'm going to perform one more lab which is related with our Terraform fundamentals. And so this lab's infrastructure has a code with Terraform. Okay, so let's verify the objective of this lab. So we are going to build, change, and destroy infrastructure with using Terraform, create resource with the Terraform, and then provision infrastructure with Terraform. Okay, so let's start. So previously we used Gemini assistants, right? And we use prompt to create a resource. Now we use code, that's our Terraform code, and as well as Gemini assist as well. So yeah, our console is open. Make sure always open in private window. Let me share it. Okay, so while it's opening, come back to our screen. So first thing we need to activate our Cloud Shell. Then we need to build the infrastructure. What we have to do, we have need to create this Terraform file. Make sure when you create any Terraform file, so .tf, that stands for the Terraform. Okay. So always Terraform files comes with the .tf. And in this main.tf, we are going to copy this code. So let's verify what is this code doing. It's connecting the Terraform with the resource provider, that is Google. Provider Google which region. It's connecting between the connection between the Google provider and the Terraform, and here it's the provider where we have the project region. Which region we have this project? This is your central and zone, central UA. What is the resource? We are just creating only network. Okay, compute network, VPC network. We are going to create that network name is Terraform network. Okay, so let's see. Here is our Cloud Shell. So what is Terraform block? Terraform block is required. So Terraform knows which provider to download from the Terraform registry, right? So this is the Terraform block, first one. You're telling the Terraform that we are going to use resource provider, that is Google. So it will download the registry from this HashiCorp Google/Google, right? So here in this configuration, Google provider source is defined as HashiCorp, which is shorthand for the registry dot. It is a short name. You can see as a short name, which is from registry.terraform.io/HashiCorp/Google, right? Provider. Second thing is the provider. You are using the provider, that is Google, and then we need to initialize. Okay, and we know this is the resource block. So let's see. I will open in a new window. So I will get editor uh, and the club I mean our terminal as well, both in a single window. We can close this. Okay. Okay. Okay, so previous session we have closed. So let's set this uh, project. Config list project command is correct. So project is not selected. So let's configure it. So because actually it was, I mean, I have one more session, right? So in that session, it was got some conflict, or maybe that project is not selected. We can select the project now as well. That's to me. So GoogleCloud config set count. Account is deactivated from this one. That's why. Checks why it is not showing. Try to open editor. Let's try troubleshooting, right? We can set it to set the active account. Yeah, I should show like this, but why it is not showing with the project some. Okay, unset. There's no set, right? So what we can do, we can set it. No problem. Always do one thing. Let's open one more session. That's yeah, that will be easy. Okay, so so here we are activating our cloud shell. Okay, that's fine. Open a new window. Authorize. Now let's open the editor as well. First thing I will see is that Gemini Assist is enabled or not. Okay, so let's enable it. And then I need to select the project. I will just go here. You can see no project, right? Google Cloud Code is no project. So I will go here and I will select a Google project, select my project ID. That's it. It shows now and fine. Now come to this open folder. You will see students ID, that is 37087. Yeah, click. Something happened. Okay. So yeah, we have selected our project. That's fine. Now Okay, so now we need to create one main.tf file. You'll see here we got the tf.file. I will copy this code, put it here. Just a second, it will automatically get saved. But still, if you want to, you can press Ctrl plus yes. And then we need to initialize. Okay, so initialization is good. Now Terraform, I will just run it, validate. So mostly it's going to be fine. Yeah, it's okay. So let's apply it. So plan is the fit. Make sure always run plan. So if you uh, so you will get the habit of before applying. It's always good to go with the plan. So you will see what are the changes going to happen, and then you need to apply it. Okay. It will prompt you whether you want to perform this action. You will need to center yes. And here you can see once we apply, as we discussed, it's automatically creating the terraform.tf state file. So it's creating the, let's go to the here, VPC network. Okay, it's created, right? Let's see. It's creating. You will see the green check mark like that, I think. Let's see. Okay, it's completed. So Terraform network. In this network, what we have, subnet, what we have given, Terraform network, your central, and then this is the IP. So IP is automatically taken, but we have given the name that is Terraform network. That is fine. Okay. So, uh, okay. So that's fine. So Terraform show what will do? It will be perform the current state. See, this is the resource. After creation, we can check here from as well. Like this is the ID, project ID. This is the name. Project is the project. This is the complete ID. Okay, sorry. Project ID is here. Project ID is here. Routing mode, regional, self link. This is the link of the network. So that's fine. So yeah, I will check create resource. Yeah, it's completed successfully. We have completed task one. Now go with the task two. So change the infrastructure. We have previous infrastructure. We have just created VPC network. Yes. Now we are going to add resource by adding them to to the Terraform configuration and running Terraform apply. Okay. So in this, now we are going to previously we have just created network resource, but here now we are going to assign instant, and that instant will have the that network VPC. It will connect it to the existing network which we have created. Okay. So what we need to do, we need to just copy, go to the main.tf, come to the 20 line, click paste. That's it. So let's verify what is showing. So here we are creating the Google. What resource we are going to create? We are going to create Google Compute Instant. And we are given the metadata, name, Terraform Instant, machine type E2 Micro, boot disk, Debian, Cloud Debian 12, network interface, network Google Compute VPC network dot name. So it will get from there. Okay. Now let's hit apply. So before apply, we will see what are the changes going to be happen. So we can select Terraform plan. Let's see. So it's going to an add, right? So you can see plus symbols. So that plus whatever you will see plus symbol that are going to add. Okay. Boot disk is going to add initialize parameters. That's all going to network interfaces are going to be add. See, network here we already have created, right? So it shows Terraform network. That is going to select that one. So then fine. Now apply. Yes. So let's before creating, let me show you. Go to the compute instance, VM instance. Okay. Here you can see it's creating. Still it's loading, right? So that means it's creating the instance. In the Cloud Shell also, it shows complete. Okay, now here you will within few seconds, it will show you tick mark. Yes, we got it. We got the Terraform instance with the internal IP and external IP. If you let's verify once, going to the Terraform instance, you can see we have given the Terraform instance name, instant ID, running, Debian 12 as per the code we have given the boot disk image that is Debian 12 bookworm. That's fine. Machine to E2 micro. E2 micro have two CPU and one GP of RAM. Very small machine configuration. Network, it's selected Terraform network, which we already have created. Boot disk, that's the same. Okay, so yeah, that's we have successfully created one instance using the code. Now we are going to use Gemini code assist. Okay, so first always you need to enable this service if you want to use Gemini Code Assist. So on the go, I will go to the my terminal. I will just copy that command. Command what is Google Cloud Service enable Google Cloud AI champion dot googleapis.com. Hit enter. What it shows. Mm, okay, the service in the required property is not currently used. Why? The project says to be currently working place. Okay, let me set it again. What is the project ID? I will select this project ID. Oh, okay, my mistake. I was selecting the student user ID, not the project ID. So make sure you need to select the correct project ID. Okay, now we are getting this wrong, right? Even though our configuration worked, that's fine. Okay, so now I will enable the service again. So make sure you need to select the project ID instead of the student ID. I was selecting wrong one, my mistake. Okay, so yeah, so Google API service has been enabled. Uh, so this one we already have done, but let's verify once. Gemini. It's okay, so enable Gemini. Yeah, that we have already done. That's fine. Let's go to this. Okay, we can see the code assist is here. So what we are going to change in the this is the prompt. Okay, in this configuration main update and VM instant, adding a tag argument, set the value web dev. So we are giving a tag name for our VM instance. So let's see. I will go to the Gemini Code Assist icon. Just put that one and hit enter. Here you can see you will get two separate window. Main it's like what is existing and what is going to be changed. In the it will show you the difference. So what is it just going to add? Okay. So when you want to generate a new code, so that time only you need to press generate. You need to click generate and then put the prompt. But if you're something you if you want to on the same main.tf in the same file, if you want to add something, so you just give the proper prompt, and it will add it. So yeah, I will click accept to make the change. You can see here tag name is added. Then again, I will type Terraform apply. Let me show you. Here we don't see the tag name. Okay, I will show you later. One second. Yes. So where we can verify the tag name, maybe here it will show you. It shows none, right? Here you can see. I think it's creating. Let's verify it's created. But why at console I don't see. Let's try to refresh. Okay, where it is not showing. Okay, let's see. Okay, this is not good. OS, we don't have authorization. It should show here tag name, but I'm not sure why it is not showing. So just try to find out in your lab if you see and put it on your command if you get the tag name in this console. Okay, so uh, maybe I'm missing or maybe I'm wrongly saying something, but tag is this one, right? As per the what it shows, resource VMS shows tag equal to div, web or div, right? Mm. Let's see changes. Yeah, that is shows completed. But guys, just try to find out if you see. Please put me on chat where I can. Maybe I'm checking on different or it should be under the tags. Which because here we are identifying we are giving the tag here only, right? For the instant we are giving our tag. Okay, so let's see. Let's go to our next tags. Now, there is restrictive change is a change that require the provider to replace the existing resource rather than updating. This usually happens because the older cloud does not support updating the resource in the way described in your configuration. So, what we are going to do, uh, we are going to change the boot disk image. Okay, so in this, I will just go to this again. I will just copy and hit enter. So here you can see we are removing it and we are adding the new image. So let's see. Right now on the console it is Debian 12 as per the previous. That's fine. Now let's see whether it's reflecting on the console or not. Okay. So let's click apply. Terraform. See, plan is very important command. What is going to change? Let's see. Previously I missed, so apologies for that. Okay. So it will just verify whatever is needed. Only one resource is going to appear. So let's see. Terraform apply. So in the console, it's got, let's see what's going to happen. Someone, okay, still it's taking time. So let's identify. So changing the decimal is one of the restrictive change, right? So it's not possible to just image will get changed. You need, so it will it will delete the existing VM and create a new VM, right? So what will happen? You will use the same code, but on the console it will get fully new VM. So the prefix and means the Terraform will destroy and create. So here you can see minus symbol means completely delete and plus symbol means it will add, which are shown with the plus prefix. With the parental prefix, changing the boot disk as secure, recreating it, right? This is the important point. When you change the boot disk, so that means you are deleting the existing VM and creating a new one. Okay. So let's see. Okay, so here you can see GitLab, this is the project it's created. Now check at the console level. Cost stable 1 to 1. Yeah, I got it. But tag still it doesn't show. Not sure why. Okay, that's fine. So we got our new boot disk image. Okay, now you destroy infrastructure. You have seen to build and change infrastructure. Moving on, multiple resources and showing resource dependency. You explore how to completely destroy your Terraform manage its infrastructures. So if you want to destroy completely or destroy your infrastructure, so you need to hit enter only one command, that is Terraform destroy, right? So let's do it. Like if you don't need, if you're, see, this is mostly used for the testing environment. So like if you're doing some testing and everything is done, so you don't need that VM because it will impact your cost, right? So you need to destroy it. It's better to destroy it. So since it's only one VM, so we can try at console level. But we are expert in Terraform, so we are going to delete it over Terraform. So I will hit Terraform, destroy, hit enter. It will confirm you whether you want to destroy. Yes. Do you really want to destroy all resources? Yes. Let's see the magic. It's deleting. That's why it's loading like that. I mean, showing. stopping right here. You can see this instance being stopped. So first, always when you click destroy, or so first the instant will get the stop and then it will get destroy. Coming to our okay, let's complete it. Then we can see the task 3. What is shows you will learn more about resource dependencies and how to use resource parameter to share information about one resource with others. Yes. In real world structure has a diverse set of resources and resource type. Terraform configuration can contain multiple resources, multiple resource types, and this type can span multiple providers. Yes, definitely. Yeah, see, any organization will have different number of resources, right, and different providers. Some may they will also use multi-cloud like AWS. Also, they use one of the instant. Otherwise, maybe Google or Azure. So yeah, it's supportable. In this session, what we are going to do, you're shown to how to configure multiple session, how to research this. Run the following command to recreate your infrastructure and instead. See, when you click destroy, or even if you delete the main.tf also, but if your tf state file is there, you will get your VM step. I will show it later. Let's try it. Okay, so it has completed. Let's see. There's no any VM. Perfect. What are the files we have? tf.state. Right. So here you also you can verify. Okay. Now see, without making any changes, can we get the same? Let's see. I will click yes. So we are going to recreate that infrastructure. We have the state tf state file. We have the main.tf file. So it will create because we have tf.state file. If state file is missing, then your VM is not possible. That I want to say. Next queue, yes, that we have completed. Let's see. Yeah, task. So we got 50%. Once it's created, then we are going to assign static IP address. Currently it's dynamic, so we are going to create a static IP address where we have given. Okay, so it's creating. Okay, completed. See, right, I will refresh it. You will see your VM now. Yeah, that's fine. Now, what it shows, static file, right? So I will go to this one, go to the main.tf. Okay, and in this you can place anywhere. I will add here, or even you can give prompt, but it is code, it is just the code, so you can directly paste it. Then I will hit Terraform plan. What is going to be change? Say this is the resource static VM, right? Okay. Okay, completed. Let's see the network details, what we see it. So this one is the okay. Sorry, my mistake. It we were giving the tag for the network tags. Oh, is it? Let's see. Mm, okay, it shows under the VM details. Uh, Day of VM. Okay, that's fine. Okay, so now coming to the this one. Yeah. So we have recreated and we have assigned the static IP address well. Now update that. Show these also. Okay, so this what it does, we have only changes to the static IP. Now we need to assign to that static IP to our what we called our VM. So net, we need to update our network interface configuration. So I will go to the trf.py network interface. So I will just this one. Okay, now let's apply. Now apply. Yes. So we are assigning that IP address to the our VM. Okay. Okay. We are going to save this plan. Okay. So what does that mean? When you do this, it will create one out of hyphen out and static IP. So it will create one more configuration file that you can use in future. Okay. So you can Terraform apply. So it will create one more VM. Let's see. Okay. We got, let's see. Okay. See. Now it got assigned, right? Previously it was showing a frill, something like that. But now it shows Terraform static IP. This is the static IP address. I will delete this one. So now the next is uh okay. So we have assigned. Now we are going to save the plan. Okay, in the static underscore IP. So to use to create one more for future use, like okay. So what I'm going to do, I just Terraform plan hyphen out and then the name of the your out plan. So you can give any name here. We can go with the same. Here you can see static IP. This is the binary file. Okay. So your infrastructure match the configuration. Okay. Now Now hit this one. So according to it, it will create, let's see. Okay, so we have completed this as well. Okay, explore implicit and explicit dependency. By studying the resource attributes in the instructions, Terraform can automatically infer when one resource depends on another. In the example above, the reference to Google Computer Static IP created an implicit dependency on Google Compute address and VM static IP. Right? So it was, yes, we have this reference. It used the reference of this one. Terraform uses this dependency information to determine the correct order in which to create and update the different resources. In the above example, Terraform knows the VM must be created before the VM instant. So, so yeah, as per the it automatically create the info network and then the VM instant. So implicit dependency via interpolation expressed as the primary way to inform Terraform about the relationship and should be used whenever possible. Sometimes there are dependency between resources that are not visible to Terraform. That depends on argument can add added to any resource as a list of resources to create explicit dependency for. Okay, here's one more example. For example, perhaps the application you run on the instant expect to use specific cloud storage bucket, but the dependency is configured inside the application code that's not visible to Terraform. In that case, depends on explicit declare the dependency. Okay. So I mean, you are defining that Terraform that you have to use the Google Cloud packet. Okay. So what we are going to do, uh, we are going to create another instance with this. We are going to use the same main.tf only, but in that same main.tf, we are going to create, see, Google Cloud VPC network self-in slash parameter cloud. Yeah, here we need to assign bucket name. Yeah, try my storage underscore 32143. So it will be unique. Always storage name need to be unique. Unique. Okay. Then plan. So what is going to change? What are the changes? Terraform will perform another instance will be get created, boot disk, initialize parameters, network interface, bucket is going to create on bucket as well. Terraform, apply, click apply. So currently we have one VM, right? So the second VM will use bucket, storage bucket, clouds. Click yes. Oh, that's some, okay, invalid bucket name. We're going to take a short. Okay, sorry, my mistake. You need to give that storage name. Is so in smaller case, I mean it should be unique, right? Not uppercase. It doesn't support. Completed. Now let's go to the storage first. It's you will see one bucket will be there. My storage, right? We got it. So bucket dependency, yes. Okay, so what it shows before moving on, we need to remove these resources from your configuration and then apply to you won't see the bucket instance in the, so we have two instances, right? Let me show you compute. In the second stage, it shows the storage will be a bucket. It's connected to the storage one. So what it shows, we need to delete the added script. So I will go to this one from where we have added this one. No, bucket one, right? Let's go to verify the code. New resource bucket. Yeah, application will be used. So here from 44 to 75, I will delete. Yes, then Terraform apply. Uh, you need to perform plan, but I will just, as per the time, our time is going, we have just only 10 minutes more. So I will delete. I will just directly go with the applied. So what is going is deleting the Terraform instance to first and the storage resource as well, which we have created. It's taking time. Provisioning infrastructure. So the compute instance you lost at this point on the Google image event, but has no additional software installed or configuration applied, right? Just we have the instance. Google have to manage their own custom operating images. Yes, instead of using your Google image, you can use your own image as well. So this is the great way to ensure instant your provisioned Terraform pre-configured based on needs. Packer is the perfect tool for this and built for Google Cloud. So you can check this. What is this Packer? Okay, Terraform use provision to upload files as constraints. So define Terraform use provisioner to upload files, run script, or install or trigger other software configuration like. So to define a provision, modify the resource block by defining the first VM instance your configuration file. So we are making as a we by this configuration we can run our script or if you want to do anything. Provisional local exit. What is trying to provisional command? Google instance. So here we are creating IP address dot txt file it will create. Is add a provisional block and says start from support map. Seeing locally execute. Create a command locally on the machine. So let's see. Still completed or Still, it's okay. I sorry, I had didn't give the value. I mean, confirmed it. Okay, it's just right. Just refresh it. Okay, successfully destroyed. Now in this existing main.tf, what it shows, we need to add provisioner. So what is provisioner? So Terraform use provisioner to upload files, run shell script, or install or trigger any software configuration management tool. So if you want to make any changes or so you can provisioner, you can do it. Here what it shows, it's we are just giving the missionary version. We don't have to worry about this. So we are getting the configuration, network details. Okay, let's see. Sorry, mistake. Here we don't need to add. Yeah, here we need to add provision. So let's validate the code. So the code is correct. Code is configuration is fine. Okay, then Terraform apply. Let's directly go with the apply because I have less time. But make sure you always go with the plan first. Terraform plan. Okay, so provisioner we have added. All right. Terraform use Terraform tenant to tell Terraform to recreate the instance. So you are telling the tenant to create the instance again. The tenant resource will be destroyed and recreated using the next apply. Let's see. See, it has been marked as train, right? Now, so just like we are blocking that instant. Now, if we once we click apply, so first it will delete the existing. Let's see. See, so must be replaced. Yes, it's destroying. It's taking time. So our task, we already have completed 100%. That's good. Okay, so failed provision and trained resource. It is a resource is actually created but fails as provision step. The Terraform will be error and mark as sustained. A resource that tained still exist but should not be considered safe to use since provisioning failed. When you generate a next action plan, Terraform will remove any tainted resource and create new resource or attempt to provision them again after creation. Destroy provisioner. Provision can also be defined that run only during a destroy operation. that are useful for performing system cleanup. Okay, so VM is restricted. That's fine. That's it. So congratulations, we have successfully completed our lab. Okay, so if you have the link for this partner.schools.com, you can try with, you can practice this lab or, okay. So thank you again. Have a good day. Bye.